Hello all, I'm back in the workshop. After a long weekend of interesting weather, a couple of gigs that I played with my band. This is another request video. Somebody wanted me to make a simple sketch that demonstrate the wiring for a simple LED hookup to Xplane, so I have this small little circuit here. It is hooked up and programmed to use the nav light and respond to that, so when I turn on the nav light, it shows a pretty blue LED for you out of my package here. I will put a link to this LED kit in my description box for you. It's pretty cool. It has lots of different colors and styles of LEDs, so something fun to play with. Like I said, I chose a pretty blue one for you here. As far as the wiring goes, it's fairly simple. With LEDs, you do need to put a resistor in series. In this little circuit, I have a 220 ohm resistor to limit the current going to the LED. It's also good to know that LEDs are sensitive to polarity. I've got one here to sacrifice for you. LEDs have a cathode and an anode. The cathode is the negative side. The anode is where you connect your power to. In this case, the Arduino board will supply power when it wants it to light. You can tell the cathode because it has a shorter lead that it comes with. You can see one of these is longer than the other. There's also a flat side, which is probably going to be difficult to pick up on the camera, but there's a little flat edge right there. And also, if you can see into the, let me get a different one. If you can see into the body of the LED, there's like a bigger section here that's a big triangle. That's your negative side. So it's short lead, flat here, and then that bigger section there is how to identify which side should be hooked up to negative. I have my power supply here. I'm going to hook up the negative side. I'm going to hook it up wrong. This is how you don't want to do it for sure. So I've got negative on the anode. I'm going to hook up positive to the cathode. Your results may vary, but let's see what happens with mine. So make sure you get the right. Again, it's a very simple circuit. I'm using pin 10 as the GPIO pin that's going to turn the LED on. You can see it's connected directly to the positive side of my LED. I've got ground hooked to the negative side of the LED, and it's through the 220 ohm resistor. I've created an example sketch called XPLPro single LED for you. This will be distributed in the examples for the XPLPro library. There's not really much to this. I've defined a pin here, number 10. I've written a couple things that I've already gone over there. I'm holding a data ref handle, which we'll define later on. This is how we access and receive information. In the setup, we're going to set the pin mode of the pin that we're using to drive the LED to an output. This is important so that the processor knows what to do with that pin, or how it's going to be utilized. Everything else here is similar to any other XPLPro. Here's a digital write to turn it off to start with. My loop only contains the X loop function for XPLPro to keep it running. And this is a good opportunity to talk a little bit about the inbound handler. I'm going to come back to that after I show you how we register this data ref. In the XPL register, which is run every time that a new airplane is loaded in Xplane, or on the first initial load, we take our variable, which we defined earlier, and this is just a handle to the data ref. It's not going to contain the information that it has in it. So all this does is give us a way to access and understand which data ref we're talking about later on. I'm just registering the data ref, and in this case I'm using the nav lights on. You could use any data ref within Xplane. Do be careful though, some of them are floats and will give you a value between 0 and 1, which you'll have to handle a little bit differently. This one is either on or off, so it's just a normal integer. This line tells the plugin on Xplane that we want to be updated when this data ref is changed. So with this line, we're going to expect that every time the data that is associated with this data ref changes, that it will call the inbound handler to let us know that it's changed. The parameters here, the 100, is that we don't want updates more often than every 100 milliseconds. That's 10 times per second, which is vastly adequate for this type of data ref anyway. The next variable here is the resolution that we want. Xplane tends to have a lot more detail than we want with some of the data refs. Like later on we might talk about receiving data that's the RPM for the engine, and it tends to come in like decimal points, but usually we don't really care if it's even more precise than every 10 RPM. So we can reduce the amount of data flow that's coming to us with this. And in this case, it's either going to be on or off, so 0 is fine. There's no need to de-res it. And then the inbound handler is is the main reason I wanted to do this video. So this is the inbound handler. This gets called anytime that one of the data refs has new data for us, or we have subscribed to that data ref to get updates. So this will be called anytime that happens. The way it passes the information to us is through this structure. So every time it's called, we need to test to see if it's the handle that we're interested in this case, data ref LED 0. That's the data ref that's associated with LED 0. Ideally, you might call this data ref navlight or something like that. It's up to you. So if that data ref changes, it will call the inbound handler. We see that it's the one that we want because we're testing the handle, and then we do something with it. In this case, I'm writing to the LED pin the value that it's sending. It sends the value of the data ref in the structure as well. I've got them all the possible ways that you can receive data right here. You have to know what type of data your data ref is. If it's a long, it will send it in long. If it's a float, it'll send it there. If it's binary data, you'll get the length and then a pointer to the buffer that holds that data. If it's an array, you get the element of the array here, and so on and so forth. I'll expand upon this in future videos, but this is the basics of how it happens. So if you have multiple data refs that you want to receive inbound, you just repeat this kind of thing right here. It's important to note that I do not, within the library for XPLPro, I do not maintain a copy of the data. I do this for efficiency and to save RAM for your applications. So once it gets through the inbound handler, that data disappears. I don't have it within the XPLPro library. So if you want to save it and do something with it later, you would make a variable that holds it yourself. I'll share this simple sketch on the Discord channel. You'll also see it on the Patreon page. And until next time, your like and subscribe on this video encourages me to make more. I appreciate your support. I'll see you in the next video.